the power analysis. And all this analysis, we've used only the series connection, parallel connection, and you just have to recall Ohm's law. Okay, so all of this, we're just using the basics of DC circuits. Now, example number 1. Okay, a DC generator has no load output voltage of 120 volts. Its armature circuit resistance is 0.95 ohms, and its field coil is separately excited. If a load rated at 2 kilowatts, 115 volts, is connected across the terminal, what power would be absorbed by the load? Okay? So, sir, nagisgot lagi kag what power absorbed by the load. Kana dahing 2 kilowatts, sir. Di ba power man na? Okay, now. Mo na akong gingon pag last meeting no nga example number 1 is medyo I have to discuss thoroughly because there are lots of complications within it nga if you're not familiar, automatic wrong jud ka. Okay? So these are just very basic nga complications. Okay, na day basic ka complications. Okay, no? So pinakasayon sa tanang komplikado. Okay. So here you have a DC generator has no load output voltage of 120 volts. Okay? Now, when a problem says that you have a no load output voltage of 120 volts, it means that is the generated voltage. Okay? So may nang klaro. So good po lang daan, you have to know immediately that a no load output voltage, if that will occur, no, or gawas na sa usa ka problem, resulti siya og no load output voltage, automatic, it means the generated voltage E. Okay? So ano, gilahi pa man gyud og words nga gigamit sir. So na man gyud na mga lain-lain nga words. Okay, nga nag-mean one thing. Okay, there are lots of words, synonyms, and so on and so forth, pero pasabutan na niya parehas ra. Just like with this one. Okay? So again, if whenever a problem says no load output, it means the generated voltage. Okay? So, given we have generated voltage E of 120 volts. You have the armature circuit resistance or RA of 0.95. So, asap to ng RA, sir? If you can recall, di ba, maumto niya ito ang circuit. Now, for a separately excited generator, you are not going to consider the field winding. Ang imuha lang i-consider is ang kanirang sa armature going towards the load. Kaning nga side ang imuhang i-consider. It's because your field winding is supplied by a separate source. So, since separate source man siya, of course, it should be given and it will not react or it will not have a reaction towards your armature. Ang imuhang separate source towards the field winding. So, bisan paog you made the field winding source voltage higher or lower, or the current higher or lower towards the field winding, it will not have an effect towards your armature circuit. So that's why, as I've said, we are only going to consider this part of the separately excited generator. Okay? Just considering only the armature side going towards the load side. So kung ano, usually mag-drawing magyutaan yun ta. Okay? So, ambot lang dere, wa man ako mabutang. Usually naa man gid ta na. Sample na di ba? Ah, di day. Tanan gid ay. Ano wa di day? Sige na lang no. So far I've already given man the the diagram. So RA is given here. So RA is saan to? 0.95. Okay? And its field coil is separately excited. So for this one, sir, even kasi wala aray labot ang field coil. Ano, gisulti pa man diha. Now for this one, just to let you know that the DC generator being considered here is a separately excited DC generator. Because at first, it was not stated. Okay, it only states that a DC generator has no load output. Kanarado diretso ra DC generator. So, ang kanida nga part diri kani nga sentence, just to let you know that this DC generator is separately excited. Okay, now, if a load rated at 2 kilowatts, 115 volts, so meaning your load, this one, this side here, your load, has a rating of 200 kilowatts. Did I? 2 kilowatts, 115 volts, is connected across the terminal. Excuse me. So connected across the terminal, meaning, dari no, these are the terminals, kaning part o kaning part. So, imagine this as murag outlet. So, ang terminals, kani siya, muna na siya ang part sa imuhang outlet. Okay, mo, paslak na ka sa imuhang load, diha, dapita. Okay? So, if mo ni ang rating sa load, okay, the load only, not the generator, what power would be absorbed by the load? So mo rin itong question, sir, nga no man sir nga, naa naman tay power sa ato ang load. Manang mangutana pa man siya o pila man kuno'y power nga gi-absorb sa load. Why do we have to answer that question if we are given with the power of the load? Now, the answer here is not 2 kilowatts. Why? Because of this word, rated. Okay? When you say rated or power rating or rated power, it means that is the maximum power the load can achieve. Meaning for this load, it can go as high as 2,000 watts or 2 kilowatts. But it doesn't mean that your load is sucking up 2,000 watts of power. No, din, sir? Yes, for example, electric fan. Di ba, imuhang electric fan, you have a varying speed of 1, 2, 3. Na pag iubang electric fan, maabot pag 4 o 5. Okay? Nyari ka sa speed 1, hinay. Speed 2, medyo kusog. Speed 3, kinakusgan. Okay? Di ba, your rotation of your electric fan is based upon the speed. Of course, the highest speed has the highest power capable. Okay? The lowest speed has the lowest power capable for that load. Let's say for example lang ha, ang electric fan nga ang speed kay 1, ang iyahang power consumption is 1,000 watts lang. For example, ang electric fan nga ang speed is 2, ang iyahang power consumption is 1,500 watts. And ang electric fan nga ang speed niya is 3, muna na ang iyahang power consumption is 2 kilowatts. Okay? So inana. Just like with aircon. Okay? Ang aircon, the more kusog ang imuhang setting, the more dako og kaons printing. Parehas ra ana. So when you say rated load or rated power or power rating, that means that is the maximum power that that load can achieve. Okay? But it doesn't necessarily mean na mo na iyahang na-absorb nga power. Mo na iyang gikuha nga power gikan sa generator. Okay? So, meaning we have to solve the power sa load this time. So, dili di ay 2 kilowatts. How are we going to solve this? Okay? Now, recall, di ba, PL is equal to VLIL. Okay. Now, sir, we already have VL, which is 115 volts. Okay? Now, usually, kanang imuhang voltage, theoretically, it will not change. Supposedly, it should not change. Because, okay, usually, if you're going to connect the voltage, okay, usually, ang kanang mga loads, kanang imuhang mga electric fan, TV, charger, mga aircon, mga laptop, they are all connected in parallel. And if they are all connected in parallel, take note that the characteristics for parallel circuit is equal ang voltage no matter how many parallel connections there are. Equal na rin ang voltage. So technically or theoretically, ang imong 115 volts nga load voltage will remain the same. Pero, nganong naamang kay theoretically, sir? In actual di ay, sir. Okay? In actual, usually, mo go down na siya. The higher the load connected is, the lower the voltage becomes. So, mo na siya ang term nga low voltage. Basig low voltage mo diha. Okay? Because, the more nagkadako ang power, okay? The more nagkadako ang power consumption, the more nagkadako ang current. Okay? Ang current nga gisupply sa load. Nya take note, P is equal to V times I. The higher the power becomes, the current also becomes higher. Pero, okay, the higher the power becomes. The more ang load na connected sa imuhang supply or sa imuhang circuit, again, the more ang load connected sa imuhang circuit, the more ang current. Okay, now recall, parallel connection. Di ba, for parallel connection, current, the total current is equal to the summation of all currents. In short, current in a parallel circuit is being divided. Okay, that's why in parallel circuit, you have what you so call as current division theorem. In parallel circuit, the current is being divided. Now, if you have lots of load connected to your supply. For example, let's say, ang imuhang power, let's say for example, ang imuhang power is 1,000 watts. For example lang. Okay? Yang load voltage is, let's say, 200 volts. For example. So, ang load current should be, ay, kasaba ba? Okay? So, ang load current, if, for example, again, 1,000 watts ang power, ang load voltage is 200 volts. Let's say, for example. So, ang current should be 5 amperes, di ba? Para 5 times 200, it becomes 1,000. Pero, what if daghan kay kag load nga gi-connect? The higher the load, the higher the current. Yang power nga gi-supply sa imuha, mura man gihapon na, 1,000 watts. So meaning, pag imuhang current ni saka, let's say, nahimong 10 amperes, kung sa may mahitabo sa voltage, para maasa-is ra ang power, mo adjust ang voltage. Okay? So, gikan sa 200 volts, okay, nya 5 amperes ang current, nahimo mang 10 amperes ang current. So, imuhang voltage, mahimo na lang, 100 volts na lang. Okay? Para mo adjust sa current nga ni saka. Okay? So, mo na nga usually ang voltage, okay, usually ang voltage theoretically should maintain the same. But in actual, it will not happen, okay, as long as the more nga nag-connect ka, nag-connect ka sa imuhang supply, okay, magkinahinay nagkaubos ang voltage. Okay? That's why also, kanang, usa sa nas mga basihan sa Tagaveco. Okay? The moment nga magpakaod kag kuryente, ilan nang i-check ang imuhang gipahimo nga balay. Uy, kani nga balay, kuan ra ni. So, one story ra man ni. Kung madako mo gani ni, kung mohimo ning 3 story, ang maximum power ani is inani lang. So, sana sa mga reason, why naagin nay, naagin nay actual nga checking ang Tagaveco. Kaya lagi nang iba-bana, kani, mansion man eh. Dako tag power nga i-supply diring dapita kay mansion eh. O dire ko ano naman eh kanang usara man ni ka kwarto. Luoy ba? Usara man ni ka kwarto o kuan na ni gamay kay nig power. No? So usa na sa rason nga nung magpataod kag kuryente naagid nay actual nga check, actual nga observation or visual checking ang Tagaveco. Aside sa ilahang i-check nga sakto ba imuhang mga gipang-connect nga mga nga mga wires, sakto ba? Same time, ila silang banabanaon ng pila kay maximum power ning balayan. Dili ra kay ni kay kuan. Na naman, it's because kanang ilang gisupply sa usa ka area, let's say sa usa ka barangay. Fix na. Okay? Nya masayop sila banabana nga oy kani nga barangay daghan di kaig ni dato kalit. Nanato lag ni dato lag kalit ning usa ka barangay. Sa 100 ka residents ang 50 ni dato lag kalit. Hindi, ang resulta, low voltage tibuok barangay. Okay? Naman na nga, kailangan yun mabana-bana og tarong. Kailangan yun nila ma-check og tarong pila kay maximum power ani. Okay? So mo na usually, dili gyud na mo change ang voltage. So here, in our computations, we will assume that voltage will not change. Okay? Again, we will assume that voltage will not change. Okay, now. Okay, so from PL, we need PL man, so nanatoy VL. Kuwang na lang is IL. Okay? Where are we going to find IL? Ano na lang dahil, no? Ani pag yun. we will only assume VL is constant if gi-state sa problem nga the load connected is at rated voltage. Okay? The load connected is operating at rated voltage. Ana, ito nang klaruhon dahil, no? So, ang imuhang rating, voltage rating will remain the same if gi-state sa problem na imuhang load is operating at rated voltage. Okay? So, akong gi-change because, nakinumdum ko, in this problem, wala man day gisulti. Wala gisulti. Unsay power nga gi-absorb sa imuhang, unsay voltage nga gi-utilize sa imuhang load. Okay, wala gisulti nga kuan no voltage load is operating at rated voltage. So wala gisulti. So unsao man sir? PL equals VL IL puros dili nato ma constant. Ang VL di ma constant. Sabi ko kilo ay kamatay. Okay? Ang VL dili ma constant. Ang IL dili sad ma constant. Unsa may gamito nato sir? Okay, now, inanin na lang. In a load, usa ra gyud ang ma-remain constant. Unsa man na ang ma-remain constant, sir? That is resistance. Okay? Ang resistance will remain constant. Once you have a made up equipment na, for example, na akay TV. Ang tibuok total resistance anang TV di na mausab. Okay, fix na na. Ang imuhang laptop, ang total resistance sa imuhang laptop, di na mausab, fix na na. Okay? Suga. Kanang lighting, di na mausab ang resistance, fix na na. So, among all the elements, resistance, current, or voltage, resistance only will be the one to remain the same. Okay? Bisan pa og gi-supply na nimo og 100 volts, 1000 volts, okay? 69,000 volts, bisag kana pa imong gi-supply, ang resistance will remain the same. Okay? So, we will now use, okay, the resistance. Sir, asa man tag resistance ani sir? Okay. Now, kato akong gipang storya no, ako nang gi-explain diri. Okay? V is equal to 115 cannot be used for VL because this is just the stated rated voltage or ideal voltage, but in reality, it will change. The only thing constant is the load resistance RL. Okay? So, imuhang load, of course, na gina resistance always. Therefore, instead of using VL, its equivalent formula will be used, which is VL equals, from VL equals ILRL. Okay? So, ang atoang VL this time, if we're going to solve for VL, we will use ILRL. Okay? So, instead ng formula IARA plus VL, we will not directly use the VL equals 115 volts because, again, the problem did not state that our load has been working at 115 volts. So, we will use ILRL. Okay? So, kani siya, no? Oh my goodness. Dali lang guys, ha? Ako sa ning presuho na kung ito'y sa baay. Okay, let's continue guys. Saba kay kung ngero ganahan mo gawas. I-cage bitaw da, hilom lagi. Okay, now. So again, recall no kani siya nga formula eh. Okay? So instead of using VL, we will now use ILRL. Okay? Because again, as I've said, your VL is not sure no nga 115 volts. So we are not sure nga ang imuhang load is operating at rated voltage. So instead, we will use the sure, the other formula nga mas sure nga na constant, which is ang resistance. Okay? Now, in solving for RL, asa mo sa tag RL, sir? Load resistance. The formula for power will be used, which is PL equals VL squared over RL. Okay? Recall, di ba? P is equal to V squared over R. You have variables for formula of power. P is equal to V times I, P is equal to I squared R, and also have P is equal to V squared over R. Now, since our load is given with the rated power and the rated voltage, then we can directly solve for the rated resistance of our load. So from the formula, PL equals VL squared over RL. So RL is equal to VL squared over PL, that is 115 squared over 2000. So the load resistance is 6.6125 ohms. Okay? Now going back to the formula, IA, di ba? E is equal to IARA plus VL. If we're going to change VL into I times R, and take note, okay, take note, current is the same. For current analysis, the armature current is just the same as the load current because, recall, they are just in series. Series na sila. Therefore, ang current equal na rin na. Excuse me. So therefore, pwede di ay taka. Sige, ato na lang ning i-common. I-common na to ang current. So I'm using here IA. Which is, pwede ra gud unta nga IL akong gamiton. So IA lang akong nabutang dere. Pa-dramatic effect lang sa aba. Okay? So, I have here used IA, no? So, pero again, technically, since IA is equal to IL, I can just use IL here. Okay? Wala na akong gadiritso. Again, para dramatic effect. So, substituting values, you have your generated voltage, 120 volts. Then you don't know your current yet, but you are given your armature resistance and you have solved the load resistance. So from here, you can solve for IA is equal to 15.87 amperes. Okay? Nga, para dramatic effect, take note, IA is equal to IL. Also, in solving for PL, we cannot use the formula P equals V times I because of the voltage. Dili man constant ang voltage. So the formula used will be P is equal to I squared R. So kaniya itong gamiton. Na-solve naman na ito ang current. Nga take note, we already know nga ang resistance is constant. So we will use this formula instead. P is equal to I squared R. Okay? Therefore, PL is equal to 15.87 squared, the current, and the resistance 6.6125. So therefore, PL is 1,665.4 watts. Okay? So as you can see, dili gid ay 2,000 watts ang na-absorb sa load. So far, any questions? Mga pangutana?
None so far, sir.
Okay, no? So hopefully, na-absorb niyo akong i-explain pag for example number 1. Let's proceed to example number 2. Okay, example number 2. If a no-load voltage of a separately excited DC generator is at 110 volts. Again, nanapod ning no-load voltage. Take note ha, when you say no-load voltage, that is the generated voltage E. Okay? So the generated voltage is 110 volts with a speed of 1,350 RPM. What would be the voltage if the speed increases to 1,600 RPM? And what if the speed is decreased to 1,100 RPM? Sir, na-di ay saan ito pag-correlate sa voltage o sa speed? Okay? Giyon sa nimo pag-come up ani sir nga E1 over E2 equals S1 over S2. Na-di ay formula nga makorrelate ang speed ug ang voltage generated? The answer is yes. If you can recall, dara no? E is equal to SPZphi over 60A. You have here the generated voltage and you have here the speed. So, again, we have a formula that will directly correlate the voltage and the speed. So, we will use this formula. Okay? Naunsaon man paggamit sa formula, sir. nga you will come up with this equation. How? Sige. Asa mo to ako? Dali lang guys, magkuha sa kog digital tab. Hindi na ako ni mag-gusto eh. Dali lang guys ha. Uy, parang mo na suga. Okay. So, open board ta. Aha. Uy, hindi mo dos. Oh, come on. Hindi mo ka mawagtang ganun. Okay, let's have a new page. Okay, so let me explain. How did we come up with an E1 over E2 equals S1 over S2? Okay, so again, we have a formula. We have a formula E is equal to SPZ over 60. Pasensya akong agi. Okay? Okay, until now, pagyapon ko masanay sa digital time. Now, we have two scenarios for this problem. First scenario is ang voltage is 110 volts at a speed of 1,350 RPM. Second scenario would be if the speed is increased to 1,650 RPM. And we still have a third scenario if the speed is decreased to 1,100 RPM. Okay, so those are our three scenarios. So therefore, since even though the speed was increased to 1,600 RPM and the speed was decreased to 1,100 RPM, our DC generator that we used is still the same. Maura gihapon, we did not change our generator. Okay? Even though we have changed to different speeds, but the generator is the same. So if you have changed, if your equipment is still the same, you have just adjusted some characteristics of it, then you can just use ratio and proportion. Okay? So akong gibutang sa dali, no, for this problem, since the generator will be the same, even if the speed is changed, the following ratio and proportion formula can be used. Pangutan na lang, naunsa na pagkaunsaa. Okay? Sige, ako na explain, no? Now, we can use ratio and proportion. So we can have scenario 1 is to scenario 2. Okay? Yung ratio na to, no? Scenario 1, that is E1 equals S1 P1 Z1 flux 1 over 60. Excuse me, A1. Divided by scenario 2 over E2 equals S2 P2 Z2 flux 2 all over 60 A2. Okay. Now, anong E1 over E2 equals S1 over S2 raman ang nahibilin ato? Okay, let's analyze. First, the speed was changed. So we cannot cancel this one because it is variable. How about the number of magnetic poles? Once you have bought a generator, even though you have changed the speed, the number of magnetic poles will remain the same. If your generator that you're going to use has 4 magnetic poles, then even if you change the speed, it will still remain 4 magnetic poles. So, therefore, P here can be cancelled out. Cancel. Next, how about the number of conductors? Again, it's still the same generator. When you change the speed, did the number of conductors decrease or increase? Answer is no. Okay? Wala na mausap ang conductor diha. Speed na may giusab. So, constant ra ni si number of conductors. Cancel out. Then you have flux. Okay? Now, there are times problem will state nga nausab ang flux. Okay? There are times that the problem will state that the flux was changed to. Or, it can be indirectly, it can be indirectly learned nga, oy, ang flux will change. Okay, don't worry, I will explain it to you later in further examples no nga. You can determine na ang flux can change. Okay? So even if the problem did not state it. For this one, there is no statement that the flux was changed. And there is nothing whatsoever that we can determine that the flux will be changed because we only have the given voltage and speed. Okay? So mura na itong given. Wala tayo laing makita diha nga ano, data nga makaprove nga ma-change ang flux. So therefore, we can assume for this one, flux is also constant. Okay? Then, 60. Samot ang 60, constant. How about the number of parallel paths? Okay? Now, when you bought a generator, for example, when you bought a generator, it was simplex lap winding. Pag change mo sa speed, it will still remain simplex lap winding. Wag yun na mausab. So therefore, ang imuhang parallel path will remain the same. Cancel out. Okay? So ang naibilin, E1 over E2 equals S1 over S2. So that's why for this one, we are left with E1 over E2, okay, equals S1 over S2. Unang kana na lang nahibilin. Gikan na na dere, no? Okay? So this is the reason why we only have this formula left. Okay? So ratio and proportion na dahil ni. So first, for the first scenario and second scenario, you have E1 is 110 volts, speed 1 is 1350. But for the second scenario, you need to determine the voltage if the speed is increased to 1600 RPM. So for this one, you just use your calculator, shift solve, E2 equals 130.37 volts. Okay? How about for the third scenario? Okay, we can still make a ratio and proportion for scenario 1 and scenario 3. Okay? Still the same generator naman na. So again, E1 is 110, speed 1 is 1350, but your speed 3 has become lesser, which is 1100 RPM. Therefore, your E3 is 89.63 volts. Okay? So sayo na kayo. Also, I will give you a tip, ha? You can also directly assume unsa man imuhang voltage, musaka or moubos. Let's say for example, our E1 is 110. When the speed was increased, will our voltage increase from 110 or will decrease? You can also make an assumption for that. Saan man, sir? Recall. Di ba? We have the formula E is equal to SPZV over 60A. As you can see, speed is in the numerator side, meaning they are both, voltage and speed are both directly proportional. Okay? So if they are directly proportional, then you can assume if the speed is increased, therefore the voltage will also increase. If the speed is decreased, therefore the voltage will also decrease. And that's what happened here in our example number 2. Okay, in our example number 2, asa naman to? Tara. Okay, when the speed was increased from 1350 to 1600, the equivalent voltage was increased, no, from 110 na himong 130. Okay, and then when the speed was decreased to 1100, the voltage also decreased from 110, it became 89.63 volts. Okay, so you can assume, you can have an assumption. So dapat ang answer na ko ni pagani ka kasolve, dapat ang answer na ko ani since the speed increased, dapat ang voltage mo increase pod. Okay? Pero pag calculate mo ni decrease na hinuon, dapat na ka mabala ka. Uy, sayop ni. Dapat mo saka akong voltage, kini saka man akong speed. Di ba? So at least you have a way of indirectly checking your answer. That is for the speed. Okay? For the speed with respect to voltage. So far, any questions? For example, number 2.
Sir, goods ka, sir.
Goods kayo. Kaysa, yung murag na ay nagmahal na to. Andali lang. Sana all na ay nagmahal. DDI, si Smart na di ay nga. Pestilan, si Smart. Kalagot. Habi na kog nanay nagmahal, si Smart na di ay. Okay. Now, sige no? pwede sad. Okay? Pwede sad i-combine. Pwede sad i-combine si example number 1 o si example number 2. Okay? Gi-combine si example number 1 o si example number 2. Pero even if gi-combine siya, ang imuhang solution mo rin gihapon. If you need this formula, then you use this formula. If you need this formula, then you use this formula. Inana ra gihapon, no? Even if gi-combine sila, pero ang ilahang pag-solve is individual. Okay? Sige, that will be your seat work today. I will let you answer this problem nga gi-combine. Okay? Try your best to answer it. Okay? Again, as I've said, even if gi-combine na sila, pero ang ilahang formula, ang ilahang solution, individual ra gyapon ang pag-solve. Okay? So, this will be your seat work. And then next meeting, okay? Next meeting na to would be on Friday. Tag twice a day, twice a week, ram data mag-meet. Okay? So next meeting, before, at the start of our class, okay, I will, no. After the seat work, I will give you a solution. I will give you a solution to the seat work I have given. Okay? So again, for now, oras. Uy, 1:30, sakto na po. Okay? So we will have a seat work wherein you're going to solve the problem which is a combination of example 1 and example 2. Then after that, I will give you a solution, okay, stating clearly unsa man di pag-solve ang nga problem. Okay? The next meeting, that would be on Friday. Take note, on Friday, on the first hour, 12:30 to 1:30, we will have a quiz. So may quiz na to, sir. Of course, ang quiz na to will be gikan sa start. Okay? Wala na nilabot. Kanirang mga problem solving, for example, okay, kaning E equals beta LV, and then kani wala na sinilabot kay problem solving naman na to exam. Excuse me. And then kani E equals SPZV over 68. Dali lang guys, ahak eh. Gihutoy ko guys, wait sa. Diba no? Hutoy man ko. Okay, this one, and lastly kaning separately excited generator. So again, on next meeting on Friday, on the first hour, we will have a quiz. One problem each. One problem for katong E is equal to beta LV. Okay, one problem for this one. And then one problem for this one, E equals SPZV over 68. And one problem for separately excited generator. Okay, that would be next meeting. So, ang first hour. So, buhaton na to sa second hour, sir. For the second hour, of course, ano din sulbon? So that you will know immediately, uy, sakto akong gibuhat. Sakto, correct ako ang answer. Uy, wrong akong answer. Sayop akong solution. 1A. Hagbong na ni. Ayaw, sa diretsog hagbong. Pag ipagsugod na to, hagbong na dayon. Okay? So, that would be next meeting. So far, any questions? Mga pangutana. Wala ray mga pangutana?
Excuse me, sir. Pwede pa reiterate sa seat work, sir, then when ang deadline po?
Okay. Now, for the seat work, of course, no? Since it's a seat work, I will be giving it today. And deadline would be supposedly, it should be until 2:30. Okay? Sir, ano 2:30 naman, sir? 1 hour, dali na kayo. No, the problem is just very basic. Again, even though, as I've said, even though it's a combination of two examples, but the way you're going to solve them is still individual. Okay? So it will not take you 1 hour, 1 whole hour. But sige, no? instead of 2:30, I will set the deadline to 3 p.m. So we'll have an extension of 30 minutes if you cannot finish. Okay, so you will have an extension of 30 minutes. So I'm going to give the problem now, and the deadline will be 3 o'clock p.m. this afternoon. Did I answer the question?
Yes, sir. Pila ka question, sir?
Isa lang ka question. Okay? So di na mo kasulon-sulon, char. Okay, isa lang ka question, no? So ayo sad nang 5 ka question nya. Pila ra ka kuan, no? Pila ra ka minutes ang inyong time. Okay, for now, kuan pa man familiarization pa man sa topic. So that's why it's very important nga I will give you a seat work para ma-familiarize mo sa ato ang gipang-solve diri, no, nga generated voltage, separately excited generator. It's very important nga ma-familiarize mo na. And what's more nga mas perfect nga way para ma-familiarize is, of course, to practice solving it yourself. So that's why maghatag jud ko og seat work. Usually mo ginay purpose sa seat work usually. Okay? So kailangan makapractice kag imuha para mas ma-familiarize nimo ang problem. So that's why seat works are given, or also assignments. Ang problema sa assignment is maglumbaan na magkopyahanay gyud. Everyone will just copy from everyone. Okay. As long as there is one source, okay, the rest of them will be copy paste. Masayop-sayop pa og kopya, ang equals mahimo pang minus. Naglibog tag tan-aw na tos problem. Uy, daghana bang minus ani ba? Or ang minus mahimo pang equals. Tanan na to sa solution. Uy, daghana bang equals ani ba? Okay. So, I believe no nga makasabot ra gyud mo sa akong gihimo. Tungod sa kadali-dali og himo sa dali og himo dili suwat. Sus ang 1 nahimong 2, ang 2 nahimong 1. Okay. So mora ba ganay problema basta assignment unya na maghimo inig last minute na kay mo bright man basta last minute na. Ang pinaka bright nga state sa usa ka engineer is kanang 5 minutes before the deadline. Okay, mo na yung pinaka-bright nga state sa usa ka engineer. Okay, any other questions?
Not so far, sir.